Okay, so I'm sure all of you guys know who Gordon Ramsay is, and if you don't know who he is, then you definitely don't own any social media at all or watch any sort of TV at all. He's famous for his show Hell's Kitchen, but that show is no longer airing, and he has a new show, Master Chef and Master Chef Junior. And I watch both of those shows. I love cooking shows. I love the cooking channel. I love all that stuff. There's so many. And I immediately thought of cooking shows when we started this project. And for example, like in one of the episodes in season 4, I specifically remember Gordon Ramsay having the children use alcohol over the fire and that causing a chemical change. Both cooking and chemistry require careful measuring and time, and both of them result in a new substance to form like a new mixture. For example, you can bake a cake using eggs, flour, sugar, milk, whatever you're doing, and it makes a delicious dessert. But like once you have made it, there is no changing it. You can't go back. Like you could try to like crush the cake or whatever, you'll just get crumbs. So you can't undo it. And once you burn it, that can't be undone as well, like in the Gordon Ramsay thing. Like we learned in class, there is 2 types of mixtures. It's homogeneous and heterogeneous. A heterogeneous can be separated in the original substances that were made. Like, for example, like fruit salad. Like, even though that's a new substance, when you make it, you can take apart the strawberries, the bananas, the blueberries, whatever you have in there, and they become their own, like they're what they started as. But like when you put them all together, it's fruit salad. But when baking a cake, that would be considered a homogeneous mixture because you can't take the sugar out again, you can't take the milk out again, you can't take the flour out again. It becomes a heterogeneous mixture, or a homogeneous mixture. Sorry. Chemical change is when the change occurs when the particles that are made up of 2 or more substances are rearranged to form a new substance. Chemical change cannot be undone. And like a match, when you strike a match, it originally is like a red or a green color, and then it turns into a black, musty, and black color. I don't know. And it has change in smell as well, and it releases off gas, like when it smokes and stuff. So when you're making a cake, do you see how that can relate to chemistry? When you put it into the oven, what do you see? Do you see the chemical change? Yes. The cake completely changes color. It turns into like a dark tan color. Good looking cake, of course. And it definitely releases heat. It's warm. You want to eat the warm cake. That's really good. And then you actually do see the carbon dioxide that gets released in the oven in the tiny holes when there's in cake, and it cannot be undone. Like I said earlier, if you were to crush the cake, it would just crumble. I'm going to show you an example. Since it is Easter Sunday, my mom is making what we call egg puff. And I didn't get a chance to record her making it, but I could show you the done deal. She mixed together like bacon, mushrooms, eggs, and bread, and it turns into egg puff. Let me show you. Egg puff is something that we eat almost every single Easter, and even though we are stuck inside this Easter, we are still making it. And I just wanted to show that because I just wanted to give you guys another example of something that can't be undone. Now that it's been cooked, it's been together, there's no way that I can specifically take everything out and turn them into their own substance again. It's permanently that way, and it changed in color. There's holes in it like the cake is, and the smell is amazing. It smells like this every Easter, and I love it. And yes, thank you for listening.